Let's graph a system of inequalities. Here is one inequality and here's another inequality, and when we graph more than one inequality we call that a system of inequalities. In this case we're actually graphing linear inequalities because if I replace this less than sign with an equal sign, this guy would look just like a normal linear equation or a linear function. And so when we replace that equal sign with an inequality symbol, we call it a linear inequality because it was a linear equation before we changed it to an inequality. Okay, let's take a look. First thing we'll start with is we'll get organized. You'll notice that I color-coded the first guy as yellow and the second guy as purple. And I'm also going to number the first inequality as 1. And I'll number the second inequality as 2. And hopefully that'll keep me a little bit more organized later on. The other thing is I'm going to go ahead and start writing this out. And I have like 3 steps for working with this first inequality. The first step is I pretend as though it's not an inequality. I pretend like it is a linear equation. And I'm hopeful that you recall what happened. Sorry, had a little boo-boo there. Anyways, I'm hopeful that you recall that when you have a linear equation and it looks something like this, that what we do is we try to make it look exactly like y equals mx plus b. There we go. And we do that because m is the slope and b is the y-intercept, and we'd like to know those two things. If we know those things, we know what the graph will look like. So in this case, the x is all mixed up with the fraction. So what we do is we will rewrite this guy, and we'll rewrite it as negative 1 over 4 times x instead of negative x over 4. And then of course we add plus 1. So for some of you folks who are curious, well, how the heck did he get that? Well, it does require some experience. I'll just real quickly write it down here. If I have negative 1 over 4 and it's times x, that's the same as multiplying times x over 1. And if you recall how fractions work when we multiply the tops across. And so we get 1 times x is x, and 4 times 1 is 4. And then it's a negative number times a positive number, so therefore we get a negative out in front. So negative 1/4 times x is the same as negative x over 4. All right, sorry, just wanted to give you a little quick background on that. Let's get back on track. Now that we have this guy in the form of mx plus b, what we'll do is we'll start with the b. We know that there's a y-intercept at y equals 1. And so what we do is we go here to the y-axis, and on the y-axis we will go to y equals 1 and we'll put a dot, and then we will go to and then we'll look at the slope. And in this case the slope, I'm going to call it m, is equal to negative 1 over 4. And it turns out there's some cool things we can do with that because of our knowledge of how fractions work and how division works and how dividing positive and negative integers works. This could be rewritten as negative 1 over positive 4, because if I divide negative 1 by 4, I'm going to get negative 1/4. And this could also be rewritten as positive 1 over negative 4. And for that reason, we actually have 2 ways to figure out the slope here. Remember, slope is rise over run. Rise over run. And in this case, if it is rise over run, in this case, what that means is that we will either rise negative 1 and run 4, or we will rise positive 1 and run negative 4. Let's take a look at both. I'm going to rise negative 1 and run 4. So I'm going to rise from the y-intercept negative 1, and then I'm going to run or go to the right positive 1, 2, 3, 4. And I'm going to go ahead and put a dot. Now the other thing that I'm going to do is I'm going to look at this other slope. This says rise 1 and run negative 4. So here I'm going to start at the y-intercept and I'm going to rise 1, and then I'm going to run negative 1, 2, 3, 4. And then I'll go ahead and put a dot. And what I want you to notice is that both end up with the correct answer. Both of these two dots are on the same line that passes through this center dot. I'm going to go ahead and put a line on the graph so we can see what it looks like. And oh, by the way, notice how for a minute we pretended like we were working with an equation and we used an equal sign, but in reality we had a greater than or equal to. So we got to look and we got to decide, is this line going to be solid or is it going to be dashed? And I have this technique where I say, if I have a crayon underneath the inequality symbol, that we will make a solid line. And if we do not have a crayon underneath the inequality symbol, then we will have a dashed line. A solid line is a line that contains solutions to the inequality. A dashed line is a line that does not contain any solutions to the inequality. So if we have a dashed line, we still may have solutions, but they won't be on the line. They'll either be above or they'll be below. In this case, we have a crayon, so we'll get a solid line. All right, so now I have graphed the line, so you can see the solid line going through the 3 dots. That's the yellow line. Let's go ahead and take a look at the purple line, inequality number 2. And again, we're going to pretend like it is y is less, is actually, well, we'll pretend like it's an equal to 3x minus 1. And for those of you that remember how to do y equals mx plus b, this one's a little bit more straightforward. There's no negative slope and there's no fraction that we need to worry about. So what we'll do is we'll look at the y-intercept, -1. That takes us to the y-axis, and we'll go to -1 on the y-axis, and we'll put a dot where the y-intercept is. And then the slope is going to be, even that's a little open to interpretation. It's the slope is 3, but what's the rise and the run? Well, 3 is the same as 3 over 1, so we can rise 3 and run 1. And just as a little tip, for this, in this case it doesn't matter. We can rise 3 and run 1, and rise 3 and run 1. We'll be fine. But in some cases where you only see this much of the graph down here, it might be handy to realize that this slope could also be written as -3 over -1. Okay, because -3 divided by -1 is also +3. Anyways, we're going to go ahead and go with the slope of rise 3, run 1. So we rise 1, 2, 3 from the y-intercept, 1, 2, 3, and then we run 1, and then we put a dot. And I'm going to go ahead and do that again, rise from this dot, 1, 2, 3, and then run 1. And then, just for the heck of it, I'm going to show you that I can rise -3 and run -1. So we go from here, -1, 2, 3, and then run -1. And you'll notice I still get a dot that looks like it's in line with all the rest. Now, I'm going to go ahead and add my pink or my purple line to the graph. And when I do, notice this time I have no crayon. And because I have no crayon in the inequality, I'm going to put a dashed line through all this. Now there's a couple of tricks in figuring out where the solutions are in this system of inequalities. First, we'll look at inequality 1. And for inequality 1, we're going to test a point to see whether the point is a solution or not. And here's the thing. Look at the line for inequality 1. What I want to know is, are there solutions above this line or below this line? And if you didn't know it, I'm telling you right now, there are either solutions above that line or below that line. There can also be solutions on the line since it's a solid line, but there's also solutions either above and below, and I'll talk about why and how we know that in just a minute. But what I do is I test a single point either above or below, and when I test that point, if it is a solution, then all the other points in that area are solutions. If I test the point above, if I test the point below and it's not a solution, then none of the other points below the yellow line are going to be a solution. And therefore, all of the points above the yellow line are a solution. So if this guy's not a solution, we shade above. If this guy is a solution, we shade below. Now, a lot of times what we'll do is we'll test the point 0, 0, because math is a lot easier with 0, 0. In other words, x is 0 and y is 0. That's the only reason we test that point. There's no reason why we could not test the point -2, 0. This is a fine point to test. And we could also test the point 3, 3. That's a fine point to test as well. All we need to know is the point that we test, is it a solution or is it not? And if it is, we shade on that side of the line. If it's not a solution, we shade on the other side of the line. So, with that idea in mind, I'm going to try 0, 0. So I'm going to test the point x is 0 and y is 0. And I do that by plugging in 0 for x and 0 for y. And again, notice how easy the math becomes. If I put 0 in for x, this whole thing here just becomes 0. So essentially, I'm just checking to see is 0 greater than or equal to 1. So I'm going to go ahead and write that out so you can see it. Is 0 greater than or equal to 1? That's the question. And 0 is not greater than 1, and it's certainly not equal to 1. So therefore, 0, 0 is not a solution to this inequality, the yellow line. And since that's not a solution, none of these points down here are solutions, but all of these points above are solutions. Now, hold off, don't get too excited. I'm just going to make a note to myself above. And we'll get back to that in a second. I don't want to shade because I'm either going to have to shade below the pink or above the pink. And so instead of writing yellow all over the place, I'm going to wait to see whether I should put the yellow just on this side of the pink below it or just on this side of the pink above it. So let's go ahead and we'll test the point 0, 0, but for the second inequality. So again, we test. And again, we don't have to test 0, 0. We could test any other point we wanted to. It's just 0, 0 makes the math easy. So we get y is 0, and that's less than 0 minus 1, which is essentially just -1. And then we ask the question, is 0 less than -1? And I don't think it is. I think 0 is greater than -1. See, here's -1, here's 0. 0 is bigger than -1. So this is not true. So we're saying that 0, 0 for the pink line is not a solution. And 0, 0 is above the pink line. It's over on this side. So since it's not a solution, solutions must be on the other side of the line, the pink line. So what we're saying is that for the pink line, the solutions must be below. And if the solutions are below, then we have some really good news. Now we can go ahead and shade all of our solutions. And I'm just going to, if you don't mind, I'm going to use a different color. I'm going to go ahead and say that all of my solutions are over here. They're below the pink line and above the yellow line. So they're all kind of in this region over here. All right, they're definitely not over here, and they're not over here, and they're not over here. And you don't have to take my word for it. You could pick a point at random. I'll use a different color, maybe green. And you could pick a point like x is 2, y is -2. And if you try something like 2, comma -2, just going to write it out so you can see it. If you try this guy over here, if you try x is 2 and y is -2, this may or may not be true. But if you try this is 2 and this is -2, it may or may not be true. But I suspect you will find that both of these guys are definitely not true. In order for a point to be a solution, like the point, let's try one that looks like a good solution. I'll bet you if we tried something like 6, 1, x is 6, y is 1. If we try this point right here, what's going to happen is if we put in 6 for x and 1 here and 6 for x and 1 here, we're going to find both of these guys are true because solutions to the system of inequalities will make both of these inequalities true. And when we graph and we shade in this region here, what we're saying is this shaded region contains all solutions. Every x, y ordered pair in this region will make both of these true. Every x, y ordered pair over here, and over here, and over here, all of these will not be solutions. These guys, this will just not be a solution. But any point over here, these guys are solutions. And in fact, because this yellow line is solid, these guys right here will be solutions as well, all the way up to, well, over here, this yellow line is no longer, these are not solutions to the system because they are above the pink line. All of the points that are on the pink line over here are not solutions because it's a dashed line. And this point right here that would normally be considered a solution if we were graphing a system of equations, this guy is not a solution. And the reason why is because it is the point where the dashed line is crossing the solid line. And because the dashed line touches right here, this guy will not be a solution either. And the good news is it's not going to be that easy to check, so we don't need to worry about it right now. But since we don't know exactly what those two numbers are, it's going to be a little hard to check. So you're going to have to take my word for it on this one. All right. I at least wanted to describe for you all the ins and outs of graphing a system of inequalities and what solutions mean and what it means to be not a solution and what the shading means and what it means when you are not in the shaded area. And I'm hopeful that you found this helpful. Oh, one more thing. For those of you that actually took the time to listen, to watch and listen the whole video, I'll give you one last little tip. This is pretty cool. I want you to notice that for the yellow line, we shaded above. And I want you to notice that in the yellow inequality, we say y is greater than. In the pink line, we shaded below. And I want you to notice in the pink or the purple inequality, we have y is less than. When we have y is less than the rest of the inequality, we will shade below the line. When we have y is greater than the rest of the inequality, we will shade above the line. That's a little trick. Just in case you didn't love this whole test 0, 0 thing, you have another way of determining whether to shade above or below a line. Shade above the line, shade below the line. All right, had to throw that last one in because I love you guys. Good luck.